This subject is movement and momentum. Go back to energy just to make sure you understand it completely. Let's move on. Forces. So, what is a force? A force is described as something acting on something else which can make it speed up, slow down, or change shape. For example, while I'm standing here now, the forces of gravity are acting on me, but I'm not moving because there's a reaction force keeping me up. Newton's second law states that force equals mass times acceleration. If I draw the triangle here for you, you can see that force at the top and mass and acceleration. So, if you want to work out the force of something, you find out its mass in kilograms and its acceleration, so how fast it's moving, and in what direction in meters per second. So the force equals mass times acceleration. Okay, let's try a question. So if we have a 500 kilogram car travelling at 30 meters per second, what is the force of this car moving? Well, first let's start with writing down the equation. F equals ma, that's m times a, and we can fill the numbers in from there. So F equals mass, which is 500 kilograms, times by acceleration, which is 30 meters per second. Altogether, this would equal 15,000 meters. Shall we go through that again? So we start off with the equation. F equals m times a, and then we add in the numbers. 500 kilograms times by 30 meters per second, and then we have 15,000 meters. Moments. A moment is described as the turning force used to open something or unscrew something. Now it's not the force itself, it's just the action of turning, and it could be either clockwise or anti-clockwise. So the equation we use to work out a moment is force times distance. Force measures in newtons, and distance measures in meters or centimeters. I'll put the triangle up here again. So we have moments would be force times distance. So let's work through an example. Imagine you have a bolt that you're trying to unscrew, and you have a 1 meter long spanner, and you use a force of 5 meters. What would be the moment? If we look here, we have our pivot, and we have our spanner, and we have the force acting down at a distance of 1 meter from the pivot. So if we try and work out what the moment is, we would take force, which is 5 meters, which is acting down, times the distance, which is 1 meter. So again, force, 5 meters acting down, and the distance of 1 meter. As we're acting down this way, it would be a clockwise moment. The answer for this would then be 5 Newton meters. As we've seen, 5 newtons times 1 meter, 5 meter newtons. Gravitational potential energy is a type of energy that an object can have. Imagine you're holding onto the wall at a height. It has gravitational potential energy because if you let go, gravity would pull you back down to Earth. But that's potential energy because it's not actually moving yet. But when it's moving, when you let go of the wall, it's gravitational energy. But if I'm holding you up, it's gravitational potential energy. So this topic has been moments and forces. Make sure you go over it to understand it fully, and let's move on to stars and the solar systems.